Alright guys, welcome to Never Stop Learning platform. It's our maths faculty Shravan. So last time in real numbers part 1 we have basically covered some numbers, right? Some numbers, and then we have done HCF and LCM. So today we will be covering Euclid's division lemma. Okay, we will be covering basically Euclid's division lemma, and also we will cover some more topics. Okay, so talking about Euclid's division lemma, so we know what is division, right? हमें पता है कि division क्या है, ठीक है? So what is division is, now we will have one dividend in the division, right? It's like 9. Okay, so we have to dividend as 9. So divisor will be 2. Okay, our divisor will be 2. So now 2 4s is 8, and we have got the remainder as 1, right? So last time हमने क्या पढ़ा था कि रिमाइंडर को हम rx बोल सकते हैं, right? We can say that remainder is rx, the dividend is px, the dividend is px, the divisor is gx, and the quotient is qx, right? We know this much. The dividend is called px, the remainder is called rx, the divisor is called gx, and the quotient is called qx, right? We know this one. We will just substitute some variables in it, okay? So for px, we will be writing a. For px, we will write a, okay? And for gx, के लिए हम b लिखेंगे, ठीक है? And for qx we will write q, and also for rx we will write r. Okay, we will just make some changes, that px can be written as a, gx can be written as b, qx can be written as q, and rx can be written as r. Okay, we have make some changes out here. So we know that px, okay, we know that px is equals to gx into qx plus rx. We know this relation, right? हमने क्या पढ़ा था कि dividend is equals to divisor into quotient plus remainder. Okay, so we'll just substitute this in this one. Okay, so a is equals to b into q plus r. So we have got this one, right? So यही हमारा Euclid's division lemma है, ठीक है? So our Euclid's division lemma is a is equals to b into q plus r. Okay, a is equals to b into q plus r. So we have to know something. हमें क्या याद रखना है कि जो रिमाइंडर होता है वो 0 से बड़ा या इक्वल्स टू 0 होता है, ठीक है? द रिमाइंडर इज ग्रेटर देन 0 और इक्वल्स टू 0 एंड ऑलवेज स्मॉलर देन द डिवाइजर, वी हैव टू नो दिस रिलेशन. ओके, जो रिमाइंडर होता है वो 0 से बड़ा या इक्वल्स टू 0 हो सकता है, छोटा नहीं हो सकता रिमाइंडर 0 से, ठीक है? और बड़ा नहीं हो सकता डिवाइजर से. ओके, सो आवर रिमाइंडर कांट बी ग्रेटर देन डिवाइजर एंड कांट बी स्मॉलर देन 0, बट इट कैन बी इक्वल्स टू 0. दिस इज आवर रिलेशन. ओके, सो दिस रिलेशन was founded by Euclid, the mathematician named Euclid. Okay, so we know what is division and lemma. Now we will talk about lemma. Okay, so what is lemma? Lemma एक चीज है, okay, like हम अब इससे हम किसी दूसरे प्रूवन स्टेटमेंट को प्रूफ कर सकते हैं. दिस इज अ प्रूवन स्टेट, राइट? हमने Euclid ने इसे प्रूफ किया है, राइट? Euclids have proven this one. So with using this, we can prove some other statement that is called lemma. Okay, हम इसी स्टेटमेंट से किसी दूसरे स्टेटमेंट को प्रूफ कर सकते हैं, उसे लेमा कहते हैं. ठीक है. So we'll move now to the questions. Okay. So here we have our question. So that every positive even integer is of the form 2q, and that every positive odd integer is of the form 2q plus 1, where q is some integer. Okay. So we know that every positive even integer. Okay. Positive integers means after 0. The number which will start from after 0, then it will be plus. So it will be positive. Okay. So positive even integer is of the form 2q. So okay now. So now we know that we'll prove this with our Euclid's division lemma. Okay. So we know that A is equals to BQ plus R. We know this relation, right? We know this relation. With this proven statement, we will prove this statement. Okay, that is called lemma. Okay, so now in the question we have 2. We have BQ. For B we have 2, right? For B we have 2. So if it is 2, yeah, B is equals to 2. So we know that R is greater or equals to 0 and smaller than B. We know this one. R is greater or equals to 0 and smaller than B. So in place of B we have 2. In place of B we have 2, right? So what we can say from this one is R can be greater or equals to 0 and smaller than 2. So two possible outcomes are there. So R can be 0, and R can be 1. So we have two possible, right? हमने क्या किया कि क्वेश्चन में 2q plus 1 दिया था, right? 2q दिया था. So b की जगह हमने 2 डाल दिया. फिर हमें पता है कि R greater than 0 or equals to 0 और छोटा है b से. So for b we know that b is equals to 2. For this particular question b is equals to 2. So हमने क्या किया, b को 2 से रिप्लेस कर दिया. फिर हमें पता चला कि r तो 0 हो सकता है या फिर r 1 हो सकता है. So for now here we will write a is equals to b. b की जगह क्या है 2. So 2q. The first r can be 0 first. So plus 0. R can be 0. And another thing is a is equals to 2q and r can be also 1. In place of r we have first put 0, then we can also put 1, right? So plus 1. So हमें दो ऑप्शन मिला है. 2q plus 0, a is equals to 2q plus 0 and also a is equals to 2q plus 1. So we have asked even integer is of the form 2q. So even पूछा है हमें even. So even means it can be divided by 2, right? So we can divide 2q by 2, right? So we can divide 2q by 2. So it is even. And we can't cut 2q plus 1 by 2 because 1 stays. So it is odd, right? So I think we have proven this question. We have cracked this question that we know that 2q plus 0 can be written as a is equals to 2q. And a is equals to 2q is even, right? And the odd is, so a is equals to 2q plus 1 is odd. So we are, in this question we have asked that even integer is of the form 2q. So even integer is in the form of 2q. And also that every positive odd integer is of the form 2q plus 1. So odd integer is of the form 2q plus 1. We have only 2. So we have got 2 options and we have proven this question and we have cracked this question. So now we'll move on to next question. So we have our next question, okay. So that every positive odd integer, okay. So that every positive odd integer is of the form 4q plus 1 or 4q plus 3 where q is some integer. So same question as last time, or we have 4 in place of 2, right? And we have to only find odd integer, not even in this question. Okay, so now we know h equals to bq plus r. We know that this is equation of equivalence, right? So we have b is equals to 4 in this question. So we will say r can be greater or equals to 0, and we know this one, right? And smaller than b. So in place of b, we will write 4. So 4, we'll just replace this one, right? So we know r can be greater or equals to 0 and smaller than 4. So we have 3 possible outcomes in this, right? Not 3, we have 4 possible outcomes. R equals to 0, r can be 0, r can be 1 because 1 is smaller than 4, r can be 2, right? R can also be 2, and r can also be 3, right? These 4 numbers are smaller than 4, but r cannot be 4 because we don't have equals to sign out here, right? If we had equals to, we can also have r equals to 4, but we don't have equals to, so we'll write just 0, 1, 2, 3. I hope इतना आपको समझ में आया होगा कि r का वैल्यू 0 हो सकता है, r का वैल्यू 1 हो सकता है, r का वैल्यू 2 हो सकता है, और r का वैल्यू 3 हो सकता है फॉर दिस पार्टिकुलर क्वेश्चन, बिकॉज वी हैव, हमें पता है कि b इज इक्वल्स टू 4 है, और हमें पता है एक रिलेशन कि r b से छोटा होता है और r 0 से बड़ा या इक्वल्स टू होता है. सो यूजिंग दैट वी हैव फाउंड 4 equations for r, right? So 4 possibilities of r. So r is equals to 0, r is equals to 1, r is equals to 2, and r is equals to 3. So now we'll just place it down here, okay? So a is equals to, for b we have 4q, so plus r. So first we will write plus r plus 0, right? We have this one, we'll term it as equation 1. And now a is equals to 4q plus 1, it can be next equation 2. R is equals to 4q plus r can be 2, this one will be equation 3, and a is equals to 4q plus 3, this can be equation 4. So now we will segregate odd and even, okay? So this can be divided by 2 and we have remainder as 0, so it is even, right? We can divide 4q by 4q plus 0 by 2, right? 4 2s are 2 2s are 4. So we have got an even value, so it is even. So now 4q plus 1, any remainder 1, or any, if we will find any remains as odd number, it will be odd. So this one is odd, the second equation is odd, third equation is even, and the fourth equation is odd again. In this question we have to find odd integer. So odd integer in this question is this one and this one. So it can be a is equals to 4q plus 1 or a is equals to 4q plus 3 for odd. So we have, is of the form 4q plus 1. We have got 4q plus 1, and also or 4q plus 3. So we have got also 4q plus 3. If the question asked us that except odd we have to find even, so we would written as 4q plus 0, a is equals to 4q plus 0 or a is equals to 4q plus 2. This would have been even positive integers, and this one is our even odd positive integers, okay? So I hope you have understand this problem. So now we'll move on to next topic, okay? We'll now cover next topic. So now we have jumped to next topic. The next topic is relation between Hcm and Hcl, okay? So हम अब नए टॉपिक में जाएंगे, ठीक है? So what is the new relation is, हम जब दो नंबर्स का मल्टीप्लिकेशन लेते हैं, प्रोडक्ट लेते हैं, so we'll take a into b, okay? We'll take a into b, so it will be equals to a into b will be equals to LCM of A and B into HCF of A and B. तो हमें क्या पता चलता है कि जब हम दो नंबर को मल्टीप्लाई करते हैं वो इक्वल होता है उस दो नंबर के एलसीएम और वो दो नंबर के एचसीएफ के साथ. ओके, सो वी विल मेक इट एज टर्म्स. ओके, सो फॉर ए वी विल राइट 5 and for B we'll write 10. Okay, so we have 5 and 10 for in replace of A and B. So now 5 into 10 will be equals to LCM of 5 and 10 into HCF of 5 and 10. So we will be knowing that 5 into 10 will be equals to LCM of 5 and 10 into HCF of 5 and 10. Okay, so now 5 into 10 is 50. 5 into 10 is 50. So now LCM of 5 and 10 and HCF of 5 and 10 will be taking off. Okay, so 5 and 10. So 5 ones are 5, 2 5s are 10 and 5 ones are 5. So for 5 it equals to 5 into 1 and for 10 it is equals to 2 into 5. Okay, so now in this 5 is common, so HCF will be 5. So into now HCF is our 5. Okay, so now we will find LCM. So LCM is 5 and 10. So 2 5s are 10 and 5 1s are 5. So our LCM is 2 into 5 and 2 into 5 is 10. So we have our LCM and HCF also. So LCM is 10, HCF is 5 and 5 into 10 is 50. So 50 is equals to 50. So we have proven this, that product of two numbers is equals to the LCM of two numbers into HCF of two numbers. Okay, so we have got this relation. So now we'll move on to questions for this one. So we will do some questions and then we will express this one. Okay. So now we have this question. Okay. Given that HCF of 10 and 20 is 10, therefore find the LCM of 10 and 20. It's easy, right? So we know that product of two numbers. So we will take the product of 10 and 20. So 10 into 20. And this will be equals to LCM of 10 and 20 into HCF of 10 and 20. So हमें यह पता है कि product of two numbers equals to होता है LCM of two numbers and into HCF of two numbers. So 10 into 20 is 200 and we have been given that HCF is 10. So into 10. So we will take LCM as X for some moments. Okay. So now we know how to solve this one, right? So X is equals to 200. So अब यहाँ पर मल्टीप्लाई है तो इक्वल्स टू के इधर जाने से क्या होता है वो डिवाइड में कन्वर्ट हो जाता है. So we know this one. So 0 cancels 0. So X is equals to 20. So हमें X का वैल्यू मिल गया है, that is 20. So now we will replace this X by 20. So 200 is equals to, so 220 into 10 is 200. So we have got the LCM as LCM of 10 and 20 is equals to 20. So I hope you have got this question. So now we'll move on to our next topic. Okay, we'll move on to our next topic. So now our next topic is fundamental theorem of arithmetic. So by name, नाम से पता चल रहा है कि ये बहुत कॉम्प्लेक्स है. तुम लोगों को लग रहा है कि नाम से ये बहुत कॉम्प्लेक्स है, पर कुछ भी कॉम्प्लेक्स नहीं है. ठीक है. सो नाउ अगर हमारे पास एक कंपोजिट नंबर है, ठीक है, वी हैव अ कंपोजिट नंबर. So if we have a composite number, this theorem says that we can write this composite theorem in type of product of the prime factors. आई गेस आप लोगों को ये समझ में नहीं आया होगा, तो मैं समझाता हूँ कैसे. अगर एक आपके पास एक कंपोजिट नंबर है, ठीक है, यू हैव अ कंपोजिट नंबर इज 20, ओके, फॉर सेक इट्स 20. So 20 can be expressed in the form of product of prime numbers. कैसे देखिए, 2 tens is 20, 2 tens is 20, 2 fives is 10 and 5 ones is 5. 2 tens are 20, 2 fives are 10 and 5 ones is 5. We know this one, right? So now composite number is our 20. So 20 can be expressed in the form of product of prime number, that is 2 into 2 into 5. So 2 is your prime number, 2 is your prime number, and also 5 is your prime number. We have got this relation that composite number can be expressed in the form of product of prime factors, product of its prime factors. Okay, so if we have 50, for variability we have 50. So now 2 25s are 50, 5 5s are 25 and 5 ones is 5. So we can express 50 is equals to 2 into 5 into 5, and we know that 2 is a prime factor, prime number, 5 is a prime number and 5 is a prime number, and these all are the prime factors of a composite number, that is 50. So we can express a composite number in the form of product of its prime factor. So this much is our fundamental theorem of arithmetic. So now we'll move on to our next topic. Now our next topic is factor tree. So what is factor tree? Is tree of factors. Okay, it's just a tree of factors. So if we'll take an example of 500, okay, we'll take an example of 500. So 2 250s are 500, right? 2 250s are 500. So now 2 1s are 2, 2 2s are 4 and 2 5s are 10. So 2 125s are 250, right? So now it can be divided by 3 also, so we will just directly divide it by 5. So 5 2s are 10 and 5 5s is 25. So 5 25s is 125, and then 5 5s is 25. So 5 5s is 25 and 5 1s is 5. So we can express this prime factorization method in form of factor tree. Okay, so how you will do this one is, you will take 500. Okay, you will take 500. So now the first factors of 500 is 2 250s are 500, right? So the number is 2 and 2 250s is 500, right? 2 into 250 is 500. Now this 250 can be expressed as 2 into 125. 2 into 125 is your 250. So 2 into 250 is 500. 2 into 125 is 250. So now 125 can be expressed as 5 into 25 is our 125. So 5 into 25 is 125. Now 25 can be expressed as 5 into 5. 5 into 5 is our 25. So now at the last we have got that 5 and 5, and these both are our prime numbers. So in factor tree, at the end we will get two prime numbers, and 5 is our prime number and also 5 is also our prime number. So this is how you do prime factorization way, and this is how you can do by making a factor tree. So I hope you have got the point of factor tree. So we'll make one more factor tree of 800. Okay, we'll make factor tree of 800 now. So 2 400 is 800, 2 200 is 400, 200, 2 into 100 is 200, and 2 into 50 is 100, 2 into 25 is 50, 5 is 25, and 5 1 is 5. So we have got this factors. Now we will express this in factor 3. Okay, so we have 800. 800 can be expressed as 2 into 400. 2 and 400. 2 multiplied into 400 is our 800. So now 400 can be expressed as 2 into 200. We can express like this. 200 can be expressed as 2 into 100. We can express 2 into 200 as 2 into 100, and 100 can be expressed as 2 into 50. Right. 50 can be expressed as 2 into 25. Right, we can express 2 into 25. Right, now 25 can be expressed as 5 into 5. So we have again got two prime numbers at the end, that is 5 and 5. We are getting 5, only 5 as our prime factors, but it's not that you will get only 5. Okay, you will get all the prime numbers in particular question, because I have 500 and 800, so I've got 5 and 5 as our prime factors. Okay, I hope you have got the point of factor tree. So now we'll move on to our last topic, that is Euclid's division algorithm. Okay, so our next topic is Euclid's division algorithm. Okay, our next topic is Euclid's division algorithm. So what is Euclid's division algorithm? We know division. What is division? Right. Algorithm means series. Okay, you will just remember algorithm is series. Just remember this one. And Euclid is our mathematician. Like Shravan is your mathematics teacher, and Euclid is the mathematician. Only the mathematician. He found this one. So what is Euclid's division algorithm? It is entire next thing of finding HCl. Okay, entire next thing of finding HCl. So how Euclid found to find HCl, we'll just see by applying the question. Okay, so we'll take 480 and 50. Question: find HCl of 480, 50 using Euclid's division algorithm. Not by prime factorization method, it is by using Euclid's division algorithm. So what you will take is, from these two numbers, which one is bigger? 480. So you will take 480 as your dividend. You will take 480 as your dividend, and divisor will be 50. Okay, divisor will be 50. तो हमने क्या किया कि ये दो नंबर में कौन सा छोटा है उसे डिवाइजर बना दिया, और कौन सा बड़ा है उसे हमने डिविडेंड में रख दिया. ओके, सो 50 9 is 450. Right, we know this. 5 9 are 45, and only 0 we have to put. Right, so now it's 30. Okay, it's 30 now. So now what we'll write is 480 is equals to 50 into 9 plus 30. Right, 50 into 9 plus 30 is our 480. So first line is covered. So now you will divide, the next thing is 50. You will divide 50 with the remainder left. Okay, you will divide 50. The next the last time division will be divisor will be your dividend in the next step. Okay, so and you will divide by the remainder left. Okay, so 30 1 ja is 30, right? So we have got 20. So write, now it's the second step, that is 50 is equals to 30 into 1 plus 20. Right, so now you will write 30 here. So your dividend will be 30 now. Next dividend will be a 30. So you will write 30. 20, 1 ja is 20. Right. Again you have got 10. So 20 into 1 plus 10. Right. 30 is equals to 20 into 1 plus 10. So now the next dividend will be a 20. So 10, you will divide 10, you will divide 20 by 10. So 10 2 is 20. We have got 0. We will not stop till then, we will get the remainder as 0. So we are in this question, we have got the remainder 0 here. So now 20 is equals to 10 into 2 plus 0. So Eclipse found that the last step divisor will be your HCF. So HCF for 50 and 480. So therefore HCF of 480 and 50 is 10. Okay, you can check it by using prime factorization method also. So now I'll overview one more. So take the number which is bigger as the dividend first, and the second number will be a divisor. So 50 is a divisor and 480 is a dividend. So now you will simply divide. 50 9 ja 450. We have got remainder as 30. So you will write 480 is equals to 50 into 9 plus 30. So now this 50, the last time divisor will be a dividend in the next step. So 50 is equals to, so now you will divide 50 by the remainder left. So 31 is 30. So 30 into 1 plus 20 will give you 50. Then your next divisor will be a dividend. So 30 is a dividend and you will divide it by the remainder left in the previous step. So 21 is 20 and you have got 10. So you will follow the same rule, and then at the last, which divisor cut off the dividend, that will be your HCF. So last step, you will just know that the statement, last step you will write the divisor will be your HCF. Okay, so last में बचता है, that gives you 10 into 2, you will give you direct 20. You don't have to write a remainder because remainder is not left, right? So the question, so the divisor which is dividing this 20 will be your HCF. जो हमारा डिविडेंड, लास्ट डिविडेंड को completely divide करता है, उस नंबर को हम HCF कहते हैं. So I hope you have understood the first example. Now we will do one more example for this one. Okay. Now this is our next question. Find HCF of 40 and 1050 using Euclid's division algorithm. So same as last step, right? Which one is greater? 1050. We will write 1050 in the dividend side and 40 is smaller. जो बड़ा होता है हम उसे डिविडेंड में लिखते हैं और जो छोटा होता है हमें उसे डिवाइजर में लिखते हैं, right? So we know this is not 40, it's 400. Okay, it's 400. So now 400 2 is 800. We know this one. So 250 remaining. So we will write this step. So 1050 is equals to 400 into 2 plus 250. 1050 is equals to 400 into 2 plus 250. Right? We have got. So now, what will be our next dividend? The divisor in the last step. So this will come out here, right? So 400 is equals to So now we'll write 400 here. So 250, 1 ja is 250, right? So we have got 150 as the remainder. So now 250 into 1 ja is 250 plus 150 will give you 400. So now what will be our next? We have not got 0 till now, so we'll simply divide again and again. So now our next dividend will be this one. So 250. So our next dividend is 250. In the last time it was divisor, but now it is dividend. Okay. So now 150, 1 ja is 150. Right, 150, 1 ja is 150, and we have got 100 as the remainder. So we'll write 150 into 1 plus 100. Now what will be our next dividend? It's 150. I hope you are getting it. 150. Right. आपको समझ आ रहा है? मैं आशा रखता हूँ आपको समझ आ रहा है, क्योंकि this is very simple, right? 150. So 100 1 ja is 100. So we have got remainder as 50 now. So 100 into 1 plus 50 is your 150. So now our next dividend will be 100. So 100. 50 2 ja is 100. So we have got the remainder as 0. So 100 is equals to 50 into 2 plus 0. So जो डिवाइजर डिविडेंड को completely डिवाइड कर लेता है और रिमाइंडर 0 देता है, वही हमारा HCF होता है. So for this question our HCF is 50. So HCF, therefore HCF of 400 and 1050 is 50. So we know this one. Okay, I hope आपको ये समझ में आया होगा. So अब हमने आज का सेशन बहुत धमाकेदार क्वेश्चन के साथ खत्म किया है, और मुझे जाने का तो बिल्कुल ही मन नहीं, पर क्या करे, जाना तो पड़ेगा. आपको भी प्रैक्टिस करना है, क्योंकि आपको सक्सेस की सीढ़ी चढ़नी है. कोई बात नहीं, ये मैच की माया हमेशा हमारे साथ ही रहेगी. और आज मैं भूल गया, हमने स्टार्ट स्माइल से नहीं किया, लेकिन हम एंड जरूर स्माइल से करेंगे. तो ऐसे ही मुस्कान रखते रहिए, सबको हंसाते रहिए, आप भी हंसते रहिए. कीप स्माइलिंग. और मैं फिर से बैक आऊँगा रियल नंबर्स पार्ट 3 के साथ, विथ फिर से धमाकेदार प्रॉब्लम फिर से हम सॉल्व करेंगे. और इस सेशन को अब हम वाइंड अप करने का समय आ गया है. तो पढ़ाई करते रहिए. ऑल दी वेरी बेस्ट.